Welcome everyone to our session on prompt engineering and function calling. I'm Darrick, and with me,
Qasim.
All right, let's get started. So for the agenda of today, we'll go through a demo that we built for this session, what we call the order copilot. Then we'll talk about function calling. Qasim will talk about the prompt engineering side of it, and then we'll get into some Q&A. All right, so let's show the demo. All right, so there are 4 cases we're going to show here. And now we're going to run the order copilot. The first case, we're going to get the status of an order. So we selected from the prompt guide, putting in a order number, and now generating that. Now we've gotten an order. Now we'll open it to actually just double check, hey, that's actually what we wanted. And it is, and it's also released. So now let's close that and look at another case. And this is from the same copilot. So now I'm removing that, and then I'm going to ask it to create a sales quote. I want 2 bicycles, 4 tires, and for the customer, the Canon group. So let's let it finish writing. Yep, and then let's generate that. And now we can see it creates a sales quote. So let's open it and double check. All right, it's for the Canon group, and it has 2 bicycles and 4 tires, just as we expected. Now let's look at another case. Say we've received an email from a customer. We don't want to parse it ourselves, so we just dump it in and generate. Let's see how the large language model will work. And now if we open the quote, we'll see that it got us similar, except it's for the office desk and office chair. Qasim will show you the email and go into details afterwards. And for the last case, we're going to show you what happens when we perform an unsupported case. So in this case, I'm trying to create a warehouse shipment, which we have not built support for. And as you can see, we've just thrown an error stating that, hey, what you're trying to do is unsupported. So these are things that you can do with function calling. All right, let's get back to the deck. And yeah, so function calling. So I'll kind of go into the what is this, why you should use it. I'll go through some very basic example use cases, and then how you can build it within AL. So what is function calling? So it allows developers to augment the capabilities of large language models by enabling it to call functions or APIs, and just based on the user's input. And I got that from Copilot. So what this also means is that with the model, it can be enhanced to interact with the system, Business Central, an external system. It can access up-to-date information by retrieving it from external sources, or perform actions beyond just generating text. So why would you want to use this? So it can enhance the interactivity where your users can now interact with your system in natural language. The model will then be able to call the appropriate functions, as we had seen in the demo earlier. And this makes the system a little more user-friendly. It can also give adaptive responses. So for example, as I had mentioned, it can provide up-to-date information by retrieving it from the system or externally, and also get the relevant information. And all this is based on the user's query. So some example use cases you could use it for. All right, in the wrong order. Data retrieval. So for example, your user wants some specific type of documents and from the last couple of days. So they could kind of just say, hey, I want the last 5 sales orders from 2 days ago. And function calling can then be used to determine, hey, what are the required filters I should put in? And then you can use that to retrieve the appropriate data that they actually want. And what if you had a customer support Copilot, for example? So the customer needs assistance with getting, say, order status. They want to initiate some returns or have some inquiries. You can build one Copilot to do all of that. So function calling will allow you to then be used to fetch the order status. It can also be used to initiate returns and then answer those queries in generative text. So I'm going to give a very basic example. If you've played with the Azure OpenAI or OpenAI function calling before, you would have seen this example back then. So I have two functions. The first one, getWeather, it takes in a location parameter. And this location parameter is just string text. And then I have a magic function. My magic function basically is an encapsulation of, it's going to catch all of everything I don't support. Qasim will talk into great detail about that later. And what you see on the right side is the function prompt. And for this one, it's the getWeather function. So now I'm going to go through two examples here. So for example, tell me the weather of Antwerp. My expectation is that it's going to tell me to call the getWeather function, and it's going to tell me that the parameter it should have is Antwerp. And secondly, I'm going to ask it, hey, tell me about the solar system. There isn't really any weather that it should be telling me to call. So my expectation is that it's going to tell me to call the magic function, and then I can handle that in whichever way I prefer, because I know what the user has intended is not supported by my Copilot. So now all the following code and stuff I'll be showing is from the demo. That project will also be shared with all of you through our GitHub, which I'll get into details at the end of the presentation. So now I have this function. It's called the getOrderStatus function. And when you want to implement your function calling, there's an interface, the AOAI function, and it needs three functions that you need to implement. There's the getName, getPrompt, and execute. So I'll go into detail for all three of them for this function. So with the getName, you want to return the name that you have determined within your function prompt. So what it looks like is here. So there's the function prompt, and the name that you have put in there is the exact name that you want to return here. Next up for the getPrompt. So this is the prompt that we had just seen that you want to return. And you can see that I'm getting it from isolated storage. We always recommend you to keep this secure, as your prompts, whether it's your system prompt, your function prompts, all these are your IP. So as such, in this case, I'm getting it from isolated storage as it's just an extension. If you have an app source app, you can use Key Vault. But the main thing is that you want to keep your prompts secure. So I'm getting it. Oh, yes, that's the same thing. I'm just checking that, hey, I actually have my prompt stored. Otherwise, I'm just going to read it in. And I'm going to return this object such that when the large language model is called, it knows, hey, I have this function. Now, one of the most important ones is the execute function. The execute function will automatically be called, and this is the meat of your function. So the arguments parameter basically will contain all the arguments. So I'm sorry, it's not all the arguments. It's the ones that you've defined that are required and potentially the optional ones. So in this case, I know that I have not mandated the order number. So I'm now checking, hey, does the order number actually exist in my arguments? If it doesn't, I'm going to throw an error. So I'm going to validate that, take it out. Next is that I want to check that maybe the large language model screwed up in some way. And it's given me an empty string for order number. And clearly, I know I cannot have an order number with no, that is empty. So I'm also going to handle that. So always validate the input you're getting from the model. And then I'm going to validate that after to see if that order actually exists within the system. And then I'm going to have my return to the call. And in this case, you can return anything, as it's a variant. You can return a record, you can return text, you can return a code unit. The options are unlimited. It's up to you how you want to use this. So now we've defined that function, and assuming we also define our other functions. How do we put this together to actually make the call to Azure OpenAI? So there's always the setup. You've set your capability, you set the authorization, and then here's the meat of it, where you want to add your tools. So I've added the 3 tools: create sales quote, get order function, and my magic function. And one of the things that you want to look at is the last line, which is set to choice. So there are two parts to this. As you can see, I've set it to auto, and that is also the default. If you don't set it ever, it will be auto. And on the other side is you can set a specific function. So when you set a specific function, the model will always call that function, irregardless of what the user query is. So for example, if I requested the order status for 100, it will call it correctly. It will tell me, hey, go check for the order status, order number 100. However, now if I ask it to tell me, hey, tell me about the weather in Antwerp, it may end up putting Antwerp as the parameter, but that is also not what I want. So and as such, that's also why we have multiple functions, for example, with the magic function to handle things that are not developed. And with auto, it will be able to call any of the functions provided. However, the key thing that you need to remember is that not only will it call any of the functions, it can also generate free text. And at that point, you want to validate that you're actually doing a function call if that is what you expect. Or if you also expect potentially generative text, then you handle it in the manner that you need to. And yeah, so then I set my system message, I add my user query, and then I call to generate. And from there, I can check. Firstly, it's like, OK, was my call to Azure OpenAI successful? I am missing a line here where you can check if it is a function call. And then you retrieve the function response. And from there, you can check if the function response was actually successful. So the reason we can do this is that when the model calls, it will then automatically call your function that was defined and was returned by the LLM. So that's why the execute function was important, is because that execute function will automatically be called for you. And you can just retrieve your result from the get result. And additionally, sometimes you might want to add context to your functions. So here's a very simple example. So I've added a variable called order type, a global variable to that function, to that GoUnit, sorry. And then I have a setter for that. Yeah, so I have a setter. And where I'm using it is in the check order axis. So in the get, that's where I'm now setting that to ensure, like, hey, for this specific type, this one exists. And where would I call this setter? So in the start order copilot function, where I've added my functions, and as long as just before your generation, you add or you set the type that you want, or set any context that you want, and when the execute function is called, the same instance will have that information. Yeah. All right. So let's take an overview from here. So in this case, now I'm asking, hey, what's the order status of this? Now it sends to the Copilot toolkit. You do all your setup, and that has the function included. And from there, you will call the Azure OpenAI service. And now that will return what function it should be calling and the parameter arguments. Yeah, so that's returned. And then within the toolkit, you will find the few functions, or it will find a few functions that you've defined and it could call, and it will choose the correct one that was defined. And in this case, is the get order status, and it will call the execute function. Yep. And from there, it will then return back up so that the toolkit already knows what the response is, and then you can, or the return is, and then you can take the response out and then see that, hey, the result is actually, this is supposed to be a sales order, and this is the order number. And then from there, you can show it to the user or call the Azure OpenAI service again. Some of you might remember this slide from Dimitri's presentation yesterday, and I hope you guys were there because it was really great. All right, I will hand it over to Qasim to talk a lot more about prompt engineering.
Thank you, Darrick. So I will be talking about prompt engineering in the context of the Copilot that was presented earlier. I will try to go through how you write the prompt for such a Copilot application, what are the different components that come together, and of course, we will be talking about functions since our Copilot is heavily dependent on functions as well. So before I go further, I want to quickly recap what we have shown in the demo. So our Copilot could do either it can create the sales, uh, yeah, either it could create the sales code, or it could get this order status, or it could do anything else. Everything else is basically to capture what is not supported. And this is also a capability itself. And I will go a bit more into details what this function is all about. I think there's a mismatch with the slides over here and over here. Now I guess they are same. So now let's look into the prompt component. What are different components that come together to build such a copilot? The very first thing that we have is the system prompt, which basically gives the context to the copilot what this AI system is all about, and then you can give a bunch of instructions to it. The second part is the function, which basically tells the model what are the capabilities that your AI system supports, and what is the communication structure with the LLM model, what are the exact response, and what are the exact arguments that you expect as a response. And lastly, we have the user prompt, which is basically what the user inputs. So now, let's look what the system prompt looks like. The first thing that we need to define is the context, which basically is to give the AI system some context what this AI system is all about. And in this particular demo, we are saying this AI system is designed to interpret emails or natural language as input and extract information to call an appropriate function. Then the second part we have inside our system prompt is called safety instructions. As part of Microsoft Responsible AI, we put a lot of effort to make sure whatever the content that is generated from the AI is safe, and we are not presenting anything which is harmful. So to do that, there are a lot of things that you can do. One of the things that we do inside the prompt is adding safety instructions. For this particular demo, we have this particular instructions that if the user prompt has something harmful content, such as threat or illegal activities, you must call magic function. And this magic function is basically which captures everything else. I will be going a bit more into it later on as well. The third section of the system prompt is the task instruction, which basically, in which section you can explain what this Copilot is basically all about, what are the capabilities, and how you want to call each capability on what kind of user input. For the very first one, if the user asks for an item that they want to purchase, we call create sales code function. Within the same instruction, I'm also putting some emphasis to make sure the name and the features are splitted. For example, if you are searching for blue bicycle, you want the blue to be a feature and bicycle as the name of the item so that you can apply filters or search differently based on different things. And I will show some example later on as well. Our second instruction is about get order status. So if the user input is about getting the status of the order, we call this particular function. And lastly, if anything which is not supported or anything which is categorized as harmful, we call magic function. So this is the entire system prompt that we have for our Copilot. The important thing over here to notice, there is no instructions about what would be the response, what would be the exact response from the Copilot, what would be the structure, and what exactly the information that needs to be extracted from the user prompt. That is where the functions come into the play. Before I show you the function prompt, few tips about writing system prompt. You should provide very clear and simple instruction. Avoid complexity. The longer your prompt is, the more tokens you will use, and it will be more costly for each LLM call that is made, since token is our currency when we are talking to LLM. Try to use straightforward language to guide the model through the process. You can always ask the Copilot to improve on your prompt. Like once you have a similar system prompt, you can always ask Copilot to refine it, to make it in simple language, or you can ask guidance from Copilot to improve your prompt as well. And lastly,
Are you pressing? No.
oops,
Yeah.
yes. Lastly, to put some emphasis on a particular instruction, you can always provide practical examples. For example, in our very first instruction about create sales code, we are talking about splitting the name and the features. And this is a problem when I was writing the prompt I faced, like the splitting was not done as expected with the model. So I put some emphasis by giving an example saying, if the user input is, I need 2 red bicycle, you should call create sales code function with bicycle as the name and red as the feature. And you can always bold any part of the prompt as well, or put stars around it to put a bit more emphasis on anything that you feel that the Copilot is not reacting as expected. So now let's look into how the prompts are basically defined. The very first prompt that Darrick already showed was the get order status. The few things that we need to define is the name and the description. Description is optional, but you can define over here and to add some more clarity for the model. But what we have experienced, as soon as you have more complex instructions, it better works to put those instructions in the system prompt rather than the description.
I mean, and also you've noticed that it's undocumented,
Yeah.
but in the description there is a maximum length that you can have, which we have found out it's about 1,024.
Exactly. And as soon as we have like multiple functions and complex instructions, the description, our experience with adding instructions in description doesn't work that well. That's why you have seen that I've added instruction when to call which functions inside the system prompt. And the next thing, which is very important, is to define the parameters that needs to be returned as part of this function. These properties will be used as an argument when the model decides to call this particular function. For example, when getOrderStatus is called, the model will make sure to extract order number from the user input and try to pass that as an argument to this function. And then you can react inside the execute function that was shown earlier in the AL side. You can use this order number to do your further processing. Let's look into the second function, which is the create sales code. Similarly, we have the name and the description. Over here, I'm not giving any description. Like I mentioned, I've already specified when to call this function inside the system prompt. And then I'm giving a bunch of parameters, properties, or you can call. I have the customer name, company name, and if I go further, I also have the list of all the items array that needs to be extracted, whatever the user has defined. I'm using an array over here, and each particular item, the information that I'm interested in is the name, quantity, and bunch of other things, including features, for example. And you can always give the type for each properties and also give some description to each property. But again, it's optional. It's up to you what works best for you. And lastly, what is very important over here is you can also define what is required for you when this particular function is called. For example, when create sales code function is called, the information that we absolutely need is the company name and some item, because to create a sales code, we need to define some customer, and we need to at least add one line. So what I'm doing over here is making sure, okay, I need the company name, I need the item array, and within the item array, at least I need the item name. If the quantity is not there, I could always default to 1, but the item name is something I'm making sure to let the model know that you need to extract from the user prompt. So now let's look at one of the examples that was also part of the demo, categorized as user prompt. So imagine you receive an email from a customer. Let's try to go through this email. In the very first section, the customer is telling about few items that he has previously purchased. In this case, black office chair and Cromson's table. And now he's asking for few other items that he wants to purchase, which is the office desk, office chair. And you can see the office chair that he is now willing to buy is actually blue, but previously he bought a black office chair. LLM will be smart enough to identify which were the items that the user is willing to buy, and which are the items that the user is only referring to. Lastly, you can see the customer and the company information is either in the email or in the footer. LLM, again, is smart enough to extract all the information from this particular email. So now, let's say you receive this email, you can copy paste inside this prompt dialog. Since this is a demo, so we use like copy pasting of the email inside this prompt dialog, but you can always build an extension to read the email directly from your inbox as well. So once you copy paste the email inside the prompt and press generate without giving any other information, the LLM will be smart enough to identify first, I need to call the functions. And then it will correctly identify, like, I need to call create sales code function just by giving this particular email as a user input. The only thing that we have previously given LLM to the system prompt and the list of functions. And when the LLM will call this function, it will try to extract all the arguments as well. And if I go to the next slide to see all the list of the arguments, you can see I have the customer name, I have the company name, and the customer email that was extracted from different places from the email. And then I also have the item array for all the items that the user was willing to buy. You can also see like the office chair that was extracted was actually blue, and all the other features that that was explained in the natural language that were also extracted from this. So this was the reason that I add the instruction inside the system prompt, because I wanted to treat the item names separately than the features, because the features, like, let's say comfortable, you have an office chair, but nothing in your system says comfortable. So I need to make sure, okay, which features are optional, which terms are optional, and which are mandatory. So that's why I added that instructions in the system prompt to do the splitting. So now let's look at the very third function that we talked about, which is called the magic function. Similarly, regarding like the other functions, we have the name and the description. Similar, like call this when the user queries not about items or status. And then we also have a property called intent, which is string, which will basically give, try to extract the intent of the user when this particular function is called. Let's look into a few examples. So when the user say, I want to create a warehouse shipment, the magic function will be called, and we are throwing this particular error. What if the user enters something which could be categorized as harmful? Is there an item I can use to harm someone? The model will be smart enough, since we have the instruction in the system prompt, it will call the magic function, and we will throw the same error. If you look at the responses from the Azure OpenAI for both of these cases, for the very first, when I want to create a warehouse shipment, the magic function was called with the intent warehouse shipment. For the second one, for the harmful content, the magic function again was called with the intent harmful content. But right now, for both of these different scenarios, we are basically showing the same error. How can we categorize the unsupported with the harmful content? How can you extend your magic function to make sure that you are showing maybe a different error or doing something different based on what kind of intent was there? So how you can do that? You can extend your magic function, the intent part of the property, and add an enum with all the possible categories that you can think of. Right now, I'm giving two categories, which is either it is categorized as harmful content or not supported content. Now, when you do the same input uh, within our as a user input, I want to create a warehouse shipment. It is categorized as not supported intent. And now you can show an error which basically says, okay, this it is not supported. In case of harmful, you can ask to rephrase or do some other nice messaging to the user. Few key points about magic function. Using the magic function, you can control the unexpected because since the input is free text, so you are never in control what the user can enter. Using the magic function, you can basically control, okay, you are redirecting everything which is not supported to a particular function and basically handling in that. And you are also basically setting boundaries to your AI features, basically what is supported and what is not supported. And lastly, you are mitigating risk and ensuring safety by redirecting everything to a magic function. One thing that we have experienced very well using magic functions regarding safety is like the model works best if you redirect any harmful content to a particular function, or the alternative would be to say, okay, if there's something harmful, don't respond. The LLM most in cases responds with something. So to mitigate risk and safety, and if you're using functions, it works perfectly like when we do our red teaming, redirect everything to magic functions, and it works pretty well. So something for inspiration, like the future of function calling. What's down the pipeline for function calling? So this is something already part of Azure OpenAI, and it will be part of our SDK in the future as well. It is called parallel function calling. I will try to explain this through an example. For example, you have two functions defined in your prompt. One is the get weather, current weather function. The other is search hotel. You have defined these two functions inside your prompt. And now, when the user input is what's the weather like in San Francisco and New York, also suggest hotel in these cities. The LLM will call the get weather function twice for both of these cities, and it will also call the search hotel for both of these cities. Now, with just one LLM call, there were 4 calls made for getting the weather, 2 for the weather and 2 for the search hotel. And yeah, in the future, that will also be part of the SDK, and then you can make some use of this as well. So yeah, that was all about the prompt engineering section.
Let's just do a very quick recap of kind of what we've just talked about. So for function calling, main points to kind of take away is that it augments the capabilities of an LLM. The functions are triggered automatically for you, so you can just get the result immediately. And you can add additional context to the functions. Whether you're using it for one copilot or another, you can generalize some of them.
Regarding the prompt engineering, like I mentioned, be concise and specific in your instruction. Start simple and see if it already works. And if not, then try to add more complexity to your system prompt. And function does simplify your system prompt because now we are not adding any extra instruction in the system prompt regarding the response. And the communication is also always structured. So you do not have to handle any of the structure like the response should be JSON, or these are the arguments in this particular format. If you define a function, the model will make sure it works as expected.
And everything is on GitHub. So the AI module is part of the system application and can be found at the BC apps repository. And for the demo that we had showed you, all this code, the prompts and whatnot, we will be putting it up on BC Tech. We have not, unfortunately, but either later in the afternoon or Monday, we will have it there for you. And let's get to some Q&A, if anyone. Okay, the questions.
Yeah, so regarding the magic function and kind of those unexpected inputs, obviously that user input, as Ayrton and Augustine point out, that's their data, but from an extension developer's perspective, it might be interesting to know, like, okay, what's going on that's leading into this path? So is it clear, like, what could we log to telemetry? Probably not the user input, but what about the intent of what the user is putting in? Can we log any of that to find out what users are trying to do with our copilots?
What we can store inside the telemetry, I guess, do you have answer to that?
I was gonna think that the enum would be fine.
Yeah.
I mean, not the query, of course, but the enum. Ayrton?
Yeah, okay, there you go. So this has been a very big question for us. Like, obviously, we want to know with all of our AI features, what kind of questions are you asking? What kind of responses are you getting? But the thing that the user types in and the response that they get back is obviously all customer data, right? Because you could write in there, like, write a sales invoice to my customer with all of these things, and that's your business information. You could even type your own name in there, and at that point, that's also personal data. So at the moment, we actually don't collect any of this information. It's very hard for us to see how the product is being used because there's all of these privacy implications to us collecting all of this data. And so, I mean, the telemetry you log is your own problem, right? Like, we make sure that we are following all of our internal compliance guidelines, that we don't log all these things to telemetry. But as far as I understand it, all the partner telemetry is stored in your own, like, partner subscription. And so then, you have your own guidelines as to how you handle that data, right? We're working on solutions internally for us to be able to store all of this information and so that we can actually gain these insights. But it's going to involve users consenting to providing this data, and obviously be able to opt out. We're only going to collect it if you actually, like, give us permission to collect this to improve the service.
But the classification of any of this data would be customer content.
Oh, yeah, anything that they type into the product and anything that comes back from Copilot is all customer content, yeah. At least from our perspective.
Just to add to that, like, at least you can record telemetry, like which function was called. I guess that's already part of the SDK as well. Or you can tell me, okay, either the magic function is called or the create sales order function is called.
Yeah, so we do actually start to track things like that, right? So we will classify the request, like, for example, for Copilot chat, like, are you looking for information or are you looking for data? But we don't know what information you're looking for or what data you're looking for, right?
I guess there was a question.
There was a question here.
So actually, the first question I wanted to ask the same about the telemetry, because it's really interesting to understand what's going on there and why you receive any response from the chat. But yeah, that's clear. So another question is it possible to find somewhere some bunch of examples of the prompts written by the Microsoft, like to handle the standard already written functions by Microsoft?
So as I had mentioned earlier, prompts and system prompts, function prompts, basic prompts in general are considered IP. So we have ours and you have yours.
Yeah.
And as such, that's why we don't, for example, with sales line suggestions, marketing text, none of those prompts are available. However, for what we have built for this demo is specifically to be given out to you guys for the same things we have done for ours, but just for this Copilot. So
Okay,
this is
clear.
I think this might be the only example that we have.
Okay, thank you.
There's over there. Oh.
Yeah.
Oh.
I want to ask how we can grant good performance if you have a customer with 150,000 items, etc.
So you can definitely not pass those as part of the prompt. So once you extract that information, I guess what was earlier shown in one of the Dimitri session was either you can use embedding and use those things, or you can use your own searching to find those items. But yeah, currently, if you cannot basically pass that kind of information to LLM, so you have to rely on some searching based on the keywords that you extract from that.
Yes, hello. Everything that we have seen so far as regards to the system prompts and the function descriptions, they're all in English, but most of our users would be writing input in different languages. Any comments on that, thoughts on what to add, or is the model?
At least our experience that even if the user's input is in another language, it still works fine.
Okay.
You do have to kind of tell the model that, for example, with marketing text, is that, hey, reply in the user's language. If you're looking for generative text.
Yes.
If it's calling a function, then it doesn't really matter for the most case what language it returns, because it's going to be a JSON and some parameters that you're going to parse.
Okay.
Add to that, you can write your prompt in any other language as well. And if, like Darrick mentioned, for marketing text, our prompt is in English, but our user input could be in any language, and the LLM will respond in that language. In fact, it also worked with emojis. If you enter and all the different things that you can input, you will be amazed how the LLM would be able to respond in either of the languages that you may input.
Okay. Thank you.
There's one up there. Oh, okay. I'll come to you after.
So when using Azure OpenAI, am I using the vanilla ChatGPT, or am I using a custom version that has more Business Central context? Or
So there is, though the models are not fine-tuned, and it's just what you have deployed. So whether it's GPT 3.5 Turbo, GPT 4.0, GPT 4 Turbo, it's your deployment that you've deployed within the AI Studio, where you've gotten it. Yeah.
okay, thank you.
Yep.
So you've also shown on one of your slides that you have already defined what content is not allowed.
Yeah.
Usually OpenAI already has a pretty strong filter on it. My question is, I have imagined a scenario that, for example, we have a customer who is in the chemical industry, and maybe we write a function for him where he can query how he can, for example, make a weed killer, and what does he have, and what kind of material he needs to do with this. Normally, this would already be not allowed by OpenAI standards. Is the implementation for Business Central less restricted than the normal OpenAI, or is it equally or more restricted?
So if you use it with our system prompt, it would be more restrictive. Yes. So the reason why we have a default system prompt for you is in case you don't provide any safety on your own, that we provide you a layer of safety already. But that can be maybe too restrictive, depending on industries and what you're querying for. So sometimes you might want to have your own safety in that sense.
So if I don't make any prompt for what is the illegal content, it would then just go. Would it then go with the standard from OpenAI, or would it just say no filters at all?
But there are some filters that Azure OpenAI automatically provides. So even if you have no instructions about the risk, for some of the industries, the chances are the model will not respond.
Okay.
But it will be less likely if you, like for chemical industry, we have to experiment. But when we did our testing, even without any instructions, some things are stopped by Azure OpenAI by default as well. So the chances are it will be stopped depending on the content.
Yeah, it's something you just have to play around and figure that out. Yeah. There you go.
Thank you.
That's the last question. Thank you.
Hello. The presentation was very good, very interesting. So compliments to both of you.
Thank you.
I wanted to ask, is it possible for a tech-savvy user to kind of like bypass the system prompt by brainwashing the model, like basically telling it to ignore the system prompt? Or does the model prioritize the system prompt and then the user prompt?
So you're talking about jailbreaks.
Yeah,
The prompts, yes. So within our default prompt or any of our features, especially, we do have to, with the responsible AI and red teaming, we do have to do tests on that. And there is a certain level that we have to hit to prevent that. And so there may still be ways that it comes through. We can't stop everything, or we do try. Yeah. So it's dependent, I would say, but it can happen.
Okay, thank you.
All right.
I guess, thank you. If you guys have more questions, you can always reach out afterwards as well. Thank you, everyone.